Yes, I was just discussing about that. We discussed about the multiple problems, like eight queens problem, and then eight puzzle problem, the traveling salesman problem. We discussed about the missionaries and cannibal problems. So these were the problem or real time problems. For that, no, we took considering it's a big problem, and then we identified a solution. So we took an initial state and then the final state in order to reach the initial state to the goal state, and then we crashed or no, we come across a multiple intermediate state spaces, right? So by reaching that states and finally we'll move towards to the goal, and then we'll move that node to the next node or that path to the next path. Finally we'll reach the destination or the goal state, right? And we discussed about the different parameters which are related to the performance measures like completeness, optimality, time complexity, and then space complexity. Also we started discussing about the search trees, and in order to find a solution to the given problem based on the tree kind of structures, if you got tree or graphs. And so when we talk about the tree kind of structures are in the search, we discussed about uninformed search as well as informed search. When we talk about uninformed search are also called a blind search. In that search, user or the program will not have any prior knowledge about what are the things to be done next. It will try to find out all the possible options. Out of the possible options, randomly it may select any one direction or any one path, and then it will check whether that is the goal state. If it is the goal state, the program will end up with a solution. Suppose that is not the goal state, again it may track back and then it will try to find out the alternate solution or the alternate path, and then it will check that whether that alternate path is in case if any node present in that path, that node is going to check whether that is the goal state. If it is a goal state, again program will end up with the goal state. Otherwise it will move on to the next state or the next path, alternate path. So by the way, so when we talk about the blind search or uninformed search, these searching techniques always doesn't have any information about what is to be done next. Blindly it will try all the possible methods. When we are trying all the possible methods, that is also called a brute force technique. It will try all the combination, all the available path, and that will try to reach the goal state. So here the complexity of this searching algorithm, which is completely based on the three factors. One is the branching factor B, and then D is the depth, and the M is the length, right? The level, right? And how path, I mean, how much cost it take to reach the destination. So based on these factors, we discussed about the depth for search as well as the breadth for search. These are the two basic search which are comes under that uninformed search. Apart from that, we'll discuss about the A plus T and other T, and then no depth restricted trees. So that we will cover in the later part also. Now, when it comes to the practical point of view, and as I mentioned in the initial 2-3 practicals, we discussed about the basic terms as well as syntax which are related to the prolog, and then we implemented a small programs, right? One in during one practical we identified the problems. No, we with the help of the PES performance and then environment and then actuators sensor, we identified the four aspects of any problem statement, right? And then we based on the problem identification, we have implemented using any one of the programming language, maybe the AI or Java, maybe the C++, based on your convenient. We have implemented. I have demonstrated with the medical diagnosis problem, right? In that we defined a multiple hypothesis, and then that medical diagnosis system will keep on monitoring or will keep on getting the information about the patients, whether if the particular patient has the combination of these symptoms, maybe combination of nausea, fever or cold or headache. Based on this composition, based on this existence, and the hypothesis is written, right? Suppose if different facts as well as all these related with the different hypothesis based on the symptom which present, and the particular patient has been identified whether the patient has maybe the diabetes or maybe the cold or maybe cancer. and based on the symptoms, no, we classified based on what type of input which feeded by the patient. So this was one of the example through that we implemented a medical diagnosis system. When you talk about your the next practical, so after that, and we learned about the relational operations as well as arithmetic operations. Also, I given a task to you to identify, you need to write a program to identify that based on the relational operators. Whenever if I enter a year and that specific year, and it's supposed to give the name of the president who were ruling that as I mean who was acted as a president in those duration. So this was the task given to you during the last practical. I hope every one of you implemented successfully, right? And if time permits, at the end of the session, I'll get the program from you, and then I'll do the demonstrations. I mean, I'll check the demonstration from your side. And in today's practical, and we will be implementing a depth first search practically, right? And depth first search concept we already know in the multiple during the what is that the virtual labs, and maybe with the different softwares I have demonstrated in the sufficient times. I hope you are clear with the depth first search. If you have any doubt with the depth first search, and then you can raise your queries, and then I'm ready to explain theoretically, and the later part will move into the implementing that depth first search. To implement this depth first search, if you are comfortable with any one of the language, and I basically I prepared a program in the prolog because this is related with the artificial intelligence. So I prepared a program in the prolog, and if you are comfortable with the other programming languages like C, C++, Java, and you can write the program in your convenient language. First I'll explain the concept once, and then sorry, we'll revise the concept, and then I'll explain the program, and then we'll do the demonstration. After that, we can go with the actual implementation. Is it clear for all of you? Any doubts? Any doubts regarding the depth first search concept? How the depth first search algorithm which works? Okay, I hope it's clear for all of you, because this is the fundamental concepts already you would have studied in the data structure itself, right? Also in our previous session, I've explained clearly about how the depth first search as well as the breadth first search algorithm which works to find a node. Can you all see the screen which I shared? This is again a PDF book, which if you want, I can zoom it. Is the diagram is visible for all of you? Anyone can quickly write in a chat box. Is the screen is visible for all of you? No. When we talk about the cyclic circulatory, or see that the DFS will not work in case of the cyclic graph or circulatory. That should be avoided when we are implementing depth first search. That we are going to cover here, and the cyclic part I'll clarify, Aman. So this is what the graph or the tree which is given for you for that. So we need to find out a goal state. This is the graph, tree given, which is root node A and followed by the two branches B, C, and then so here D, E, and it is keep on extending. So in this node, right, what I'm going to do is that I'm going to identify, I'm going to find a goal state, So that, so here what will happen, suppose if the tree consists of cycles here, so here this will keep on rotating here only, and so this will not come away from this path. Suppose uh, if the cycle exists between the two nodes or two vertices b and h, so d and h, sorry, and so it will go from d to h, and then it will go from h to d, so this will form the cycle. So this visit or will not come away from this, or backtracking will not be possible from this position. So to avoid that, so we need to check some conditions. Suppose if the node is already visited, and so directly that's supposed to backtrack to the previous node to avoid the cyclic. I am trying to show the graph again where it is. Sorry, this is what the diagram which I was supposed to show you. So for this diagram only, I have found a program. So you can see that this is the root node A, and it has the two child node B and C, and B as the two child, which is D, E, and then D as EH, and then E node which has the two child, which is I, and then J. Again, very similar to that, when we comes to the right subtree, C node which has the two child, which is F and then G, and then F as the child K. Out of that, so A is the root node, right? My goal node is to be J and then F. The nodes are which are circle and double circled. So that are the goal nodes. So now can you just tell me how this will reach F and then, sorry, J and F are the goal nodes. What are the path how this will reach the node J when you talk about the depth first search? Can anyone quickly write in the intermediate node? It has to path, it has to cross. First, it may start from, when we talk about depth first search, right? First, it will complete one left subtree, and then only it will move to the right subtree. So, what is my first goal node, which is J? First, it will move to that. Maybe it move to the right subtree, or it may move to the left subtree. First, A to B, and then so it finds that is there any child is exist. In case of child is exist, again it will move to the first child, and then that node will be expand, visit, and then expand. After that, it checks that is there any subtree or any child is exist. Yes, it will check, and then that will expand. After that, it checks that whether H has any node. It doesn't have. Again, it will backtrack to the previous node D, and then D to B. Again, the right subtree of the B is missing, which is not yet visited. Again, so from B to E, and then from E, its first subtree is I will be visited, and there is no child for this I. Again, it will backtrack to E, and finally it will reach J. Right? So these are the, so you can find that, so these are the different state spaces through which it reaches the J. A, B, D, H. Again, it backtrack E, I, and then H. When it comes to F, directly it starts from here A, C, F. That's it. We reach the goal state. Suppose if it is wanted to reach G, directly it will A, C. First, it will visit all the nodes which is there in the left subtree of C, F, K, and then it moves to node G. Is it clear for all of you, the diagrammatic explanation for the given diagram, how we may find our what are the intermediate node we have to reach, or we may need to pass to reach the goal state. According to the given diagram, our goal state is to reach J as well as F. Is it clear for all of you? For this problem, the pseudocode which I'm going to explain now. See, I was not able to prepare the PPT. I'm directly using the textbook which is written by the Ivan for a prolog. You can refer this prolog book which is written by Ivan, already uploaded in the ASC lab also, right? And so here, for the given problem, if you wanted to find a solutions, right? Solution is which is written as a SOL solution, and n is the goal state for the given node n, some goal node which is to be, we are going to check that whatever the node which we are going to select, or whatever the node we are going to have the goal node. If n is a goal node, then solution should be that which is we are going to represent the array of n. If there is a successor node n1 of n, that means that in order to reach a node n, suppose if we have in between there are any successor, and whatever the goal, whatever the node which you are going to visit in between, so which helps to reach the goal node, so that will be represented through this the array which n of solution 1, solution equal to n comma solution 1. So here n comma solution 1 is that, here the solution 1 which are refers to that the intermediate path through which we are going to reach. So here again the solution 1 which can be again, so this n comma n1. So here the solution 1 again which may be, the n is the goal state and then n1 is the intermediate state. Very similar to that. So here with respect to this diagram, sorry. Here with respect to this diagram, suppose in case if I am considering this E is my goal state, right? Again, A is the starting node and then N1, I mean B will be the what N1. By the way, again when it comes to here again, so this will be the say for example, if J is the node, again A to B, so this is the N node and then N1 again. From here when it moves to the next state, again next again, so this is again N1. By the way, so this will periodically the changes the values from one node to other node, and whenever it reaches the new node, it checks that whether that is the goal node or not, and then if it is the goal node and the program will end, and then the number of node which is visited, that will be registered or printed. Otherwise it will keep on moving by stating this, moving this place. Suppose if this is the notation, solve n comma n1 comma solution 1, n is the goal state and n1 comma solution is the one, or the intermediate state or the state space search, and finally it is going to reach a goal state which is a goal n. So by the way, so this process which will be keep on repeating unless until it reaches the goal state n. So this process which is going to be repeated as many times. Suppose if you have 10 intermediate nodes in between our initial state to goal state, and so this process will be repeated every time it is going to check whether that is our goal state or not. And finally, if it is reached the goal state, and so that is going to extract, that is going to print all the nodes which are visited. Is the concepts or the pseudocode is clear for all of you? How the depth first search algorithm works? Thank you, Bharat. And I'll open the program also now. I'll share the entire screen if possible. So here, this in the bottom, so this is what the program which are through which I'm going to demonstrate how the depth first search algorithm works. So these are the thing which I have, the notations are the fact which are related to the tree which I have written here. What is my goal is that F node F is the goal. Can you recall the diagram? So here, yes, node A, B, C, right? And I'll minimize this also. So here you can see that the goal is the F node and J. I mentioned here in the program goal F comma goal F and goal J. So here in the diagram which is represented here, this the vertices which are double circle, that is are goal nodes J and then F. So here you can find that. So I'm mentioning that the parent as well as child relationship using S in bracket A comma B. So that means that A is the parent of B. So matlab B is the child of A. So which is I indicated here S A comma B and then S A comma C. So this line which gives the meaning A is the parent of C. Is it clear for all of you? Like this, I am mentioning, I am noting all the nodes or the vertices which is present in the given tree using the standard notation B comma D. It represents that B is the parent of D and then C comma F, sorry, right? B comma E. So again, that is that E is the parent, sorry, E is the child of B. Very similar to that, in order to represent this, S of D comma H, that represents that D is the parent of H. Very similar to that, how so this will H will be I will be represented again A of S of E comma I. That means that E is the parent of I. Very similar to that, S of J comma E, right? So S of E comma J and then E comma I. Very similar to that, how this F will be represented S of C comma F and then S of F comma K. Also, how this G will be represented S of C comma G here, which is mentioned S of C comma F, S of C comma G. So these nodes which represent that or this fact which are represents are the tree which are shown in the diagram. Is it clear for all of you? I hope it is clear for all of you and I'm getting the quiet responses also. When it comes to the program, as I mentioned in the previous the pseudo code, right? First, I am going to consider about. So this is my the fact or the variable which I am going to use, right? This is actually the fact, and followed by node is my what is the node which I am going to represent is the node n, which is which whatever the node which I am going to select, whether J or F. So that is going to be my goal node, and the solution is that I if this is the goal node, I am going to implement using the depth first search, and I am going to implement this the list, because all these variables, whatever the state spaces which I am going to transpose, right, through the different states searches, all this that is going to be considered or that is going to be listed and that is going to be represented, and the node comma solutions again. So this is going to be implemented using this here in the empty list, whatever the path which I'm going to visit, right, that is going to be stored here, and finally it is going to compare whether the node is a solution or not. Very similar to that, how the depth first search algorithm which is going to work means that whatever the path which we are going to move based on the depth first search algorithm which works, right, and we are going to check that whether the node is the goal node, and followed by that node and the path. So here this is the combination of the next node or the successor node and followed by the cost, and it is going to check that whether it is the goal state. What is this symbol? This symbol represent the if statement, and so this is going to be considered whether it is the goal state or not, right? By the way, if this is happens, and by the way, it is going to keep on repeating these steps, and path comma node comma solution, which is going to be that. So here this is again the successor node, right? So here, yes, whatever the node which we are going to mention, a b c d e, and for all the nodes it is going to say, for example, if it is the a and followed by, it is going to visit for b. If it is the b and b followed by, d is going to be visited. Again, when it comes to backtrack again b, again it is going to visit e. Very similar to that, all the number which are going to be visited for the given node and based on the given path. So here, so we are going to check that there should not be any cyclic. So because the two nodes which comes under the cyclic graph, so that should not be no repeated. So and then automatically back to the previous nodes and to avoid the cyclic formations. And finally, it is going to check that whether the available or the node which we visited in the successor node, whether that is the goal node or not. If it is the goal node, again the program will end up. Again, there are some constraints. So this again, which is related to the depth first search with the limited depth. Sorry, I mean, see, suppose if the tree depth is exists more than certain level, and based on the condition, so here we are going to check that if the depth is more than a particular threshold value, and that can be stopped in that level, automatically the subtree can be checked. So for this program, so what we did is that, so we are going to concentrate on the first two blocks, and we are not going to concentrate on the depth. So this is not required now. But when we compile this program, so this is what the command we can give, solve a comma solution. A, what is that? This is a solve, and a comma solution, which is going to be that a node is the initial node which I am going to select, and then solution will be the destination node which I wanted to reach, right? If I enter this, the solution which I am going to get is that this is what it start from this end, right? A is the initial node, and followed by that it reached b, and then e, and then j, right? It does not, so though it is visited all the nodes, but it it gives only the information about in the right subtree. If you want, I'll open the diagram also. What are the thing which is, when we talk about theoretically, the node a is a starting node, A to B, B to D, and then D to H, and it will backtrack to here, and then E, and then I, and then J. But when it gives a program, it does not consider about the node which are visited unnecessarily, and other than that, the unnecessary visit, it gives only the actual results, which is A, B, E, and then J. So in the program, we have written the two goal state, goal J and then goal F. When it execute this program, it will give the two outputs. One is the solution to the first goal node, and if I press or operation, and that will give the other solution to the goal 2, which will start from A, C, F. Again, I'll show the diagram, which is A, C, F. Right? Is it clear for all of you? If you have any doubts, you can write in a chat box. So by in the similar way, you may write, or we can write a program for the breadth first search also. And there is no constraint with the language, what we use. and you can use your own comfortable language to write a program for that. Any doubts? I hope theoretically, I mean, I've explained in the previous session also. And if you have any doubts related to the basic concepts or the core concepts, how the depth first algorithm, breadth first algorithm. So here, this is for the easy understanding. I took a simple program, and otherwise also we can take with the complex program, or maybe the other type of program. We may change the node or the tree success based on that, and we may find out the different path through which we can reach the goal state. I'll share the code with you in the drive, right? You can make the modification in this program, and then you can start executing, and then you will find, or you will observe what are the variations, what are the things we can do, and I mean changes can make in this program, so that so you will get a more clarifications. Any doubts, guys? This is just to give a taste of DFS, how the DFS searching algorithm works. Otherwise, also in the next practical, and no, we'll have the some other types of program, right, through which maybe with your comfortable language, maybe C or Java. I'll come up with the other programs also. I'm ready to explain that also. We'll do that if required. Any doubts? Why no responses from your side? There are 34 students, including me, sorry, 34 participants, including me. Okay. So I just wanted to remind you that you all got the notification regarding the TCS interview, right? TCS, which has been scheduled in the month of October. Is it correct, Bharat? Yesterday, madam posted in the group, in the official group regarding your placement, right? And all the eligible students, right? No, don't waste your time. So we are taking tremendous effort to make you know, give the time management in all types of the verbal abilities, as well as the aptitude trainings. Make use of all kind of training sessions, and no, be prepared, and try to be ready yourself for facing the interview. This is what from my side I can say, and what are the supports you require from our side, and we are ready to support at any time for you guys. And what we need to use that, and you all need to be, you know, keep curious about preparing for the interviews. Don't waste your time, and without wasting your time, right, be ready, keep on prepared for that your interviews. That's all from my side, and if you have any queries you can write, otherwise we'll end the today's session. And so this will be the